My name is Tracey Steig. I'll be giving the next presentation. This was a talk developed by Kevin Kumagai at HTI, but he was unable to attend. The title of the talk is What's Available, What's New, and What's Next in Acoustic Tag Technology for Fisheries Research. So what's next? Well, we're developing an autonomous acoustic tag data logger. What's now? Well, we have a Predation Detection acoustic tag, or a PDAT tag. And what's new? A marine tag and hydrophones that operate at 80 kilohertz, as opposed to our existing tags, which operate at 307 kilohertz. So a few things that has led to the development in advancing our technology have been improved manufacturing techniques. One thing that has been surprising is how many 3D printers are available these days and how you can utilize these printers in your manufacturing process, which we do. Battery breakthroughs. Battery technology is continuously developing, and newer and smaller batteries and higher power density in the batteries are moving the direction, advancing the direction of our field significantly. Different frequency tags, like I mentioned before, but the fact that we can use these on the same receivers independent of what frequency tags are operating at. And like any process, the evolution in the software to make systems simpler and easy to access, and also multi-system synchronizing, is really some things that are advancing our technology. Also, the software improvements for remote access are much easier and faster than they've ever been in the past. We do this for almost any of the studies that we conduct. We set them up with cell modems, and we can log into them, check the performance of the system. We can change the operating parameters and download the data. It's just an incredible way to now conduct studies. So what's next? I'm going to talk about autonomous data loggers. The ones that we're developing are going to provide a compact acoustic data detection system without cables. Everything's in one data logger that can be dropped and go. It'll be interchangeable with how our existing data loggers and receivers work. The data files will be the same, and so it'll make it very easy to merge and combine files from multiple data loggers or our autonomous data logger and a receiver. And also, these data loggers can be configured to either operate for our 80 kilohertz tags or our 307 kilohertz tags. And we're taking advantage of the new low-power signal processors to allow us to get longer life out of our autonomous data logger. And it allows us to get longer life, or we can use smaller batteries to have a smaller package, depending on what the application requires. And as with our other systems, you can merge the data and analyze the data and possibly analyze it for 2D and 3D tracks during your post-processing, along with our acoustic data loggers and our acoustic tag receiver. So what's now? Well, over the last 2 or 3 years, we've developed a Predation Detection acoustic tag, a PDAT. For a lot of researchers, they tag a fish, but they would also like to know whether the behavior that they're investigating is that tagged fish, or is it been preyed upon by another fish, because there could be a very different behavior seen by the fish that is tagged or a predator. And so we recently developed this tag to directly determine if predation has occurred. Here's an example of a study at Georgiana Slough, and the flow is from the top of the screen down, and this is the Sacramento River main stem, and this is Georgiana Slough. And this is just an example of 4 different Chinook smolts that have been tagged with our acoustic tags and migrating downstream. 2 of them went through the main stem, 2 went through Georgiana Slough. This is typical of a Chinook smolt behavior. We've seen many examples of this, that at some other time we see tags come down that were originally implanted in Chinook salmon smolts, but they showed very different behavior. In this example, a very tortuous milling behavior, but in this example also, there's two tags that are co-located through the track, and these were originally both tagged, implanted in Chinook smolts, but obviously they've been preyed upon by their behavior. They've been preyed upon, and now both tags are within the same predator. But we're doing this with looking at behavior. We wanted to get a direct measure of predation. So just in general terms, how we develop this tag, the tag include batteries, electronics, and a transducer at the end of the tag. And so for our predation tag, basically what we've done is on the outside, we've included a digestible fuse. So what this fuse does is when the fish is preyed upon, the fuse digests and it breaks that circuit. And so you have an open circuit, and that's detected by the electronics. And when that occurs, then it changes the signal that it is outputting to give us a direct indication of predation. So this is just a schematic of how we period encode our signals. We have a tag period that is repeated over and over and over with a subcode to increase the number of codes that we can identify. So what we do and this is an example of our existing tag code, when we have a predation signal, this subcode changes in every other ping. And so we can directly identify when the predation has occurred. And this predation trigger is a non-reversible event. This signal design also allows us to keep that, it preserves the tag code and subcode, but also gives us an indication of predation. And we call this an echogram that we often look at. This is an hour's worth of data and period ID of this tag and the subcode. And after a trigger event occurs, then every other one of these subcode pings, one is the predation event and one continues with the subcode. So you keep the ID intact for the tag, but then you include another subcode that shows that it's been triggered as a predation event. And here's just an example of some real data utilizing predation tag. Chinook smolt was implanted with a predation tag, and it swam downstream down the Sacramento River to the first location, the FPT location. And at this detection site, it was determined that predation had occurred. But this predator continued to swim downstream past these detection locations, past the SAC detection location, all the way down to the TMN location. And it went up and back a couple times before eventually coming back up the STMDN and STM up, and including all the way back up to FPT. So there's an indication from its behavior that it was preyed upon at some point, but we wouldn't have known where in this predation it occurred except for the direct measurement of the predation tag. It also points out that predators may show similar behavior to an unpreyed upon Chinook smolt going downstream past these detection sites. So you could be fooled to think that this fish survived all the way down the river, but in fact it was a predator that was swimming all the way down the river. And we've seen many examples of this. Finally, the main reason we developed this was just to determine overall survival of fish as it travels along a migration route. And survival does not include predation. And this is one way that we could determine whether predation actually occurred, whether these fish traveled all through the migration route or predation has occurred along the way. In the past, we've inferred predation by the behavior, 3D behavior of the fish, but it's not absolutely definitive. And using this predation tag, we can definitely determine whether predation has occurred or not. And it's an internal trigger as opposed to an external trigger or an accelerometer. This allows us to definitively answer whether predation has occurred. PDAT tanks have been demonstrated in controlled experiments and in field tests. And this PDAT digestible fuse can be added to any of the HTI acoustic tags, including the new marine tag. So we're really excited about that. Talking about the marine tag, we've developed a marine tag that we currently are doing a study at Friday Harbor on San Juan Island, utilizing our tagging rockfish utilizing 80 kilohertz tag. As I mentioned, it's 80 kilohertz tag, and it can be tracked, the ID determined for hundreds of tags simultaneously, very similar to our 307 kilohertz tag. For the detection, you can use our regular HTI acoustic tag receivers and data loggers, and they're interchangeable for either 80 kilohertz or 307 kilohertz. The only thing you have to change is the hydrophone. The data loggers and electronics are all the same. You don't need to retool all your electronics. And like I mentioned, you can track large numbers of fish. You can, since it's in the marine environment and it's low frequency, very long ranges that you can detect that. And you can get 3D positions from these 80 kilohertz tags, just like our 307 kilohertz tags. And it's new, and we have it available now. If you're interested, Dr. Louise McGarry will be presenting a talk tomorrow, Tuesday, August 18th, at the Oregon Convention Center. And her talk is Better Understanding Through Detailed Behavior, a Marine Telemetry System to Monitor Fine-Scale Movement and Behavior. And I invite you to go to that talk tomorrow afternoon. So with that, I'll entertain any questions. Thank you.